All right, now we're going to talk about stretches and shears. Dilations aren't actually in your syllabus, but I think they're interesting to talk about. They're sort of an application of stretching. But when we talk about stretching, we're talking about scaling either the x or y coordinates by a factor of k. And then we call this a stretch, and it's going to be parallel to either the axes. When we do it in both directions, that's what a dilation is, for k bigger than 0 or contraction for k less than 0. Okay, so when we stretch, the parallel to the x-axis, y coordinates stay the same, but the x coordinate is scaled by k with scalar multiplication, and vice versa. And with a shear, the points on the x-axis remain fixed, but then the points off are translated by the amount ky. So I like this image, first of all, because it's Einstein, and then second, because it shows our images. So we've got our first image. Here's our coordinate down at 0, 0 at the origin. So if we rotate it, the point stays the same at the origin. When we shear, so this is shearing parallel to the x-axis. So these points stayed the same, but now this point has shifted to the right. So the y-coordinate has stayed the same, but the x-coordinate, so in this case, it's sheared by the amount ky. So that one would be ky. And now this one would be x plus ky, y. So this is assuming that down here is our point x0, 0, 0. This is a horizontal stretch. So I started with my points 0, 0, x0, we'll call this one xy, and 0y. So in this case, now my points on the y-axis have remained the same, but now this point is going to be kx, this point, kxy, and of course, this point remained the same because kx, well, my x-coordinate here was 0. And in this case, we can see that our k value would be less than 0. So we've shifted, sorry, not less than 0. If it was less than 0, it would have come over, it would have reflected over the y-axis as well. So k is going to be between 0 and 1 because it's gotten smaller, so it's fractionally scaled. So based on this knowledge, we can come up and make our transformation matrices. So our transformation for a stretch, I'll call that ST, parallel to the x-axis. So if we're stretching parallel to the x-axis, that means our x values are scaled by k, and our y values stay the same. If we're stretching parallel to y, our x values stay the same, and y gets scaled. Sorry, this would get multiplied by xy, so our x wouldn't actually be in here. If we shear, so I'll call that shear parallel to the x-axis. So in this case, our x values, we're taking our x values and increasing them by ky. So x plus ky, and the y value remains the same. If we shear parallel to the y-axis, the x values are going to stay the same. Sorry. Our first x value stays the same, but our y value is going to have kx added to the y coordinate. So there's our matrix transformations for these stretches and shears.